Gauss's law to find E. A part is due to point charge. B part is due to a shell, charge on a shell. Charge on shell. A part. E due to point charge. You have a point charge. Due to this point charge, you have electric field E. Electric field lines move out of a positive charge. You have to find out E at any point P, which is a distance R. Notes band kar. 1 minute to try. You have to apply Gauss's law. You have to start from Gauss's law and find electric field at point P, which is at what distance? R. Result is already known to you. Gauss's law, as per Gauss's law, EDS is equal to what? Q by epsilon naught. Step 1 for all Gauss's application is draw a Gaussian surface. In this case, it is a sphere. So, what we have is Gauss's law and its application. Today's lecture and next lecture also. Step 1 in all questions, next 4-5 questions, draw a Gaussian surface. If you draw a Gaussian surface here, it is a sphere. E, magnitude of E, will be same at all points. Why? They are at a same distance. Symmetrical distribution, same distance. That is why you can take E out. What you have is integration of ds. What does this thing mean? ds is a small area. Say this one. This is ds. Total means all, total area of a closed surface. So, total area of closed surface, this particular case, it is a sphere. For this, the value is 4 pi r square. E into 4 pi r square is q by epsilon naught. What you get is E is equal to q by 4 pi epsilon naught r square. What was the result in question number 7? Electric field force per unit charge. It was q by 4 pi epsilon r square. What was the result in question probably 9? Field, number of lines q by epsilon divided by area 4 pi r square. Same result you are proving again and again. Electric field due to point charge at a distance r is q by 4 pi epsilon r square. 1 minute to complete. 1 minute to complete. If you want to plot the graph, it is of this type. How? E will vary with R. Yes. E is inversely proportional to R square. As R increases, E decreases. B part deals with what? B part deals with E. You have to find out E due to charge on a spherical shell. How you make it? Like a table tennis ball. Take some metal powder or paint and paint it on the table tennis ball. If you paint it on the table tennis ball, then it becomes a conductor. If you place some charge, this charge will reside on the surface and the lines will move out up to infinity. Lines move radially outward to infinity. We have to find out E inside and outside. So, we need to find out E inside and outside. This value is capital R. Case number 1. Inside, we have to find out E inside. When you say inside, if it is x or small r, what is it? X or small r as a function. How? Yes, so that we are on the same note. R. We have to plot E as a function of r. That means what? Small r varies between 0 to capital R. We'll discuss this part equal to at the end. Inside. So, take a point, say this one, P, which is at distance R. We have to find out E at this point. Step 1, yes, draw a Gaussian surface. EDS is equal to charge contained divided by epsilon naught. What is charge contained inside? There is no charge inside this. Why? Charge resides only on the surface. Charge inside is 0. So, it is 0 by epsilon naught. E into ds is the right side is what? 0. E into 4 pi r square is 0. E is equal to 0 divided by 4 pi r square is 0. So, what is the value of E in? What is the value of electric field inside? 0. Simple competition. Is there any line inside? No. E represents what? Number of lines per unit area. There is no line inside. So, E is 0. That is why E in is 0 and the graph for this is E in is 0. 2 minutes with you, 3 minutes. Complete it. Here it is equal to also, because when R is 0, it is 0. Case number 2, yes, outside. When you say outside means the point lies from the surface to infinity. It is any point, that means say this one. So, if it is outside, then R varies from, yes, surface to infinity, from capital R to infinity. Same procedure, step 1, you have to write Gauss's law and then Gaussian surface, fine. Draw a Gaussian surface. Oh, at what distance? Where you want to find out the field? At point P. First step in Gauss's law, EDS is equal to charge enclosed by epsilon naught. 1 minute with you to try. What is the charge enclosed now? total charge on the surface is capital Q. What is the charge enclosed? Yes, what is the charge enclosed? Q. It is Q by epsilon naught. E, yes, magnitude of E at all points remains the same. Why? All these points are at equal distance. This point is also distance r. All points are at distance r. So you can take E out. ds means what? Small area. Total area of a closed surface. In this case, it is a sphere. Try. This part is equal to what? Surface area of a sphere. It is E into 4 pi r square is equal to Q by epsilon naught. E is equal to what? E is equal to Q by, take 4 pi r square to the denominator. It is 4 pi epsilon naught r square. So E out, that is outside the shell, it is inversely proportional to r square. Outside, E is inversely proportional to r square. And for this point, where it is equal to capital R, for this value E is equal to Q by 4 pi epsilon naught r square, so you can write it equal to also.